All right, this is the last of our notes for Unit 5. We're going to talk about solubility. So we've actually already talked about states of matter. If you didn't get those notes, go back to 5.1 notes. They are going to include it. They're also when we talked about diatomic elements as well as reactions. So we're moving on. This is the last of the notes. It's 5.5. We're just going to talk about solubility. So in some of these reactions, like this one up here, I said that copper chloride and hydrogen sulfide are aqueous. They're AQ, which means they dissolve in water. So let's think about this for a second, what dissolving in water means. Well, I think you guys kind of know this. If you try to dissolve salt in water, it will dissolve. If you try to dissolve sand in water, it doesn't dissolve. So when something dissolves in water, you can mix it into water and it kind of disappears. It's a little more complicated than that, and we're going to get into that. There's a whole unit on solutions and solubility that's coming at us. That is going to be Unit 10, I believe. That'll be in the fourth quarter of the year. That and acids and bases, some of the coolest, most important units, especially for AP chemistry. And just like life, they're pretty cool. But anyways, we will get there. So for right now, we have to determine if any individual species in an equation, in a chemical equation or reaction, is likely to be dissolved in water. As we do more of these reactions, this will start to make a little bit more sense. But basically, we're going to determine today whether or not ionic compounds are S or AQ, solid or aqueous, when they're put into water. If they don't dissolve, kind of like sand just sinks to the bottom and it remains a solid. Coffee grounds are also something that are not soluble in water. Plenty of stuff in coffee is soluble. The reason that coffee has that kind of coffee color is because it has a whole bunch of molecules that turn it that color, that make the solution that color. Same thing with tea. But certain parts of the coffee are not soluble. So it would be partially solid, partially aqueous. So what we're going to do for this one, these are the notes, and I basically just said all of that. There's something that you're going to use to help determine that. And there is on the back of your periodic table, this is a solubility chart. And it's going to help you determine if something is solid or aqueous. So let's take a look at this and we'll see what it means. It's a little strange to look at, but once you figure it out, it makes perfect sense. Okay, so it's divided into two halves. This first half says compounds containing the following ions are generally soluble in water, meaning aqueous. So any of these compounds, if you see any of these ions showing up, most likely it is aqueous. However, there are exceptions. These are the exceptions that are insoluble, S for solid. So you can just read this across. So if you have lithium, potassium, or potassium sodium, or ammonium, which is a polyatomic ion, remember, there are no exceptions. So these are always soluble. So anytime you see any of these, it will always dissolve in water and it will always be aqueous. The same is true for nitrate and acetate. Those also have no exceptions. Chlorine, bromine, and iodine, though, have some exceptions. So most of the time, these are soluble, unless they are with silver, mercury, or lead. Then they are not soluble. They're insoluble. Sulfate is the same. Sulfate tends to be soluble, except with calcium, strontium, barium, or lead. Okay, so that's the first part. The next part is compounds containing the following ions are generally insoluble in water. These are S. So anytime you see these, they tend to be insoluble. Carbonates, chromates, phosphates, hydroxides, and sulfides. There are exceptions, though. These ones are the exceptions. And it's the obvious, lithium, sodium, potassium, and ammonia. That makes sense because up here we said there are no exceptions. So that makes sense. Nitrates is probably also true, except for actually none of these can be combined with nitrates, so never mind. That's why it's not on there. That makes sense. They're cations and anions. For hydroxide and sulfide, lithium, sodium, potassium, ammonium, sure, but also calcium, strontium, and barium. So these are all really good things to know. That's how we use this, but let's actually do some examples and you can see how this works. So let's look at number 2 right now. So we've got lithium hydroxide, LiOH. So let's look at our table. We need to see if anywhere on this table lithium or hydroxide is mentioned. Right away, I can see that lithium is an ion and it tends to be soluble, and there are no exceptions. If we look down here at hydroxide, hydroxide tends to not be soluble, except it is with lithium. So lithium hydroxide, according to this chart, is definitely soluble. So right after it, I'm going to put on this sheet AQ. So it's asking for aqueous or solid. I'm just going to put AQ because that means aqueous. You can write out aqueous if you want as well. All right. So let's try another one. FES. All right. So let's take a look, and we want to see if we see iron anywhere listed here. And take a look. I don't see Fe anywhere. However, we also have S, the sulfur. So let's see if sulfides are mentioned. Oh, right here. Sulfides are generally insoluble unless they are with, nope, iron's not on the list. So that means that it is insoluble because it's in the section that says it's insoluble, and it's not one of these exceptions. So that means that iron is not going to be soluble in water, which means it's going to be solid. So I'm just going to use an S to represent solid and put it in little parentheses. All right, let's try another one. How about ammonium nitrate? So taking a look at our sheet here for ammonium nitrate, see if we can find that. I'm going to give you all a second, see what you all think. You can pause this. Okay, it is definitely aqueous. Ammonium is always aqueous. Nitrates are always aqueous. There's no exception. This thing is going to dissolve really, really well. So we will call this one aqueous. Okay. Let's try another one. Calciums. Yeah. Yeah. Oh, this one's interesting. So calcium, this is calcium nitrite, and I don't have nitrites on my sheet. So we might have to look that one up. You guys should remind me next time we're in class. Okay, we can try another one though, just for fun. Potassium iodide. I think you guys can kind of figure that out at this point. It's got potassium. It's going to be aqueous. Iodides also tend to be aqueous. So, all right, that is the process. So I want you guys to try these. We'll do a couple in class as well, but these, it's a pretty quick thing. You just look at, as long as you know how to use this table correctly, it's pretty quick. For the rest of these, you can think about some chlorides that are soluble and ones that are insoluble. You can think of any based on this chart. The same thing here for testing water for phosphate ions. What you want to think about here is what metal could you add so that it would become insoluble. So precipitation means solid. So you're producing, your product will be something that's insoluble. So think about any sort of phosphate, anything that would force phosphates to come out of solution. Looking at this list, it seems like there's some exceptions, but anything aside from these would do the trick. So yeah, at this point, you can totally do page 7. That's page 6. Page 6 is actually very cool. We'll talk about it in class. Page 8. Page 8 is the same thing. It's reminding you, you can practice writing the names and the formulas, and you can also come up with solubility. And then at this point, you actually know everything because page 9 is the test review. Page 9 and 10 is everything that you need to know for the test. So at this point, you've basically finished, we finished the whole unit. Let's check in with my YouTube channel to see if it has anything exciting, if there's any cool videos to share about this. I do have one. There's a solubility video from Bozeman Science, so that can be very cool. I might throw in a couple extra videos. Maybe I'll search the internet and see if I can find some other cool stuff related to this. But at this point, we are done with the content. So my goal, I hope for you all, is that you have mostly finished all of these notes. Hopefully things are making sense to you. And if they don't, you can ask me for help. I'm always around. Just email me or talk to me in class, whatever. Whatever's left of this unit, we will spend just reviewing and practicing and giving you time to get that help. So, um, excellent. Good luck with all of that. I'll see you soon. The next unit is stoichiometry. So we're going to take um, all of the things that we've learned about reactions and we're going to do some cool like math with them. We're starting to get really into the nitty gritty of stuff. This is all of the stuff that you need to know. We're coming in so that second semester is applications of all of that. It's where all the really fun labs and stuff. You got to be able to do this math and understand what a chemical reaction is, what formulas, what ionic formulas are, what covalent formulas are, what chemicals are, what these things mean, and then we actually can move forward. So I'll end there and I'll see you all later. Thanks, y'all.